Hello students, welcome to the second video in our example problem series for Circuit Analysis 1 at NDSU. This episode we're going to focus on KVL, or Kirchhoff's voltage law, and we're going to solve this circuit right here. As we can see, we have a voltage source, current through a 100 ohm resistor IX, the voltage across a 500 ohm resistor V1, current through a 400 ohm resistor I1, and a voltage across a 350 ohm resistor Vx. We are given that Ix is equal to 50 milliamps and Vx is equal to 3.5 volts. Okay, we're going to use KVL to solve these circuits. We're going to treat them as individual loops. Our first one is here. Our second one is here. Let's label it loop 1 and loop 2. What does KVL tell us? The voltage around this closed loop is going to sum to 0. All the voltages in loop 1 are going to sum to 0, and all the voltages around loop 2 are going to sum to 0. So let's focus on loop 1 for right now. We don't know what VG is, and we don't know what V1 is, but we do know what Ix is. And from that knowledge, we can solve for what the voltage across that 100 ohm resistor is using Ohm's law. The voltage across that 100 ohm resistor is going to be Ix, which is 50 milliamps, times the resistance, which is 100 ohms. It's going to give us 5 volts. Okay, just for the sake of completion, we are going to do the KVL around loop 1. We're going to start right here. Let's write this down, KVL at 1. Okay, so they're all going to sum to 0, so we're going to put 0 equals, and we're going to start at this dot and move upward. The first thing we meet is a negative VG plus the voltage we just calculated, 5 volts, plus V1, and that takes us back to where we started. Now, that's one equation and two unknowns. We don't like that. We don't really know what's going on. So, let's go to the next loop and try to maybe glean some more information about this circuit. Okay, we still don't know what V1 is, and we don't know what I1 is either, but we do know what Vx is, the voltage across this 350 ohm resistor. From that, we can find the current that is going through the 350 ohm resistor, as well as the current that's going through the 400 ohm resistor. So, I1 is going to be equal to, whoops, sorry about that, Vx over 350, which is going to give us 3.5. Convenient numbers, huh? 3.5 divided by 350 ohms. This is volts. I should have labeled that. It's going to give us 10 milliamps. That is I1. Okay, so we know a little bit more about this loop than we do the last one. Let's do KVL. KVL at 2. 0. Let's start here. Why not? We're going to start at the bottom, right there. 0 equals negative V1 plus our I1 times our 400 ohm resistor. That's going to give us a voltage, right? So 10 milliamps times 400 ohms. That is a voltage now, plus the voltage the voltage that we're given, Vx, which is 3.5, and that's it. Let's solve this equation, which has one unknown in it, for V1. V1 is going to be equal to 4 volts plus 3.5 volts. V1, 7.5 volts. Okay, we have what V1 is now. Let's substitute that back into our first equation. So we have one equation, one unknown. 0 equals negative Vg plus 5 volts plus 7.5 volts. Vg is equal to 12.5 volts. We've solved the circuit. Thanks for watching.